Grade 10s, here we go. Last lesson in the measurements. Did all the work with conversions, then we started talking areas and leading to surface areas. Well, last lesson we looked at surface areas of prisms. Now in terms of prisms, it was important with prisms that we identify and set up the equation ourselves, or the formula. We had to consider what were the faces. We had to do sketches and say how many of certain things there were, and then do the calculations, setting up our own formula. Well, there are some shapes where they're made up of, the faces that make them up aren't nice shapes that we're used to. And so when we talk about surface area of cylinders, spheres, and cones, we get the formulas given to us. If you check your formula sheet, you will see the surface area of cylinder, sphere, and cone is given to you. So with that, it means you don't have to come up with the formula. You just have to substitute in the appropriate values for that given formula. But you have to make sure you understand what the different formulas are. So we're going to walk through these three. Make sure you understand the variables and what makes up the surface area of these shapes. But I'm going to add on a couple extra questions. So please make sure now that you have some extra paper so that you're going to be able to sketch or jot down those questions that are a little bit more than what we have in the notes. So the first shape we're dealing with is the surface area of a cylinder. A cylinder is special because a cylinder it is a prism, and it has two bases, which are circles. So we can look at this and say, well, we have two circle bases. But when you unwrap and get the net of a cylinder, you end up as well with one big rectangle. The dimensions on that rectangle, a little bit tricky, not required to figure that out in this course, so we give you all the information. So the formula, if we take a look at it and we think about it, a cylinder, it's kind of like it has a label. I always look at cylinders and think of soup cans. So you have a label going around, and that's what we could think of the rectangle as. The surface area is made up of one rectangular label, but because it has goofy dimensions, it's not just length times width, it's 2 times pi times the radius of your circular base times the height of the cylinder. And then what else makes up the surface area besides that label? Well, we do have the two circles, and there's nothing special with that. Two circles would just be pi r squared for one circle times 2 of them. So this formula is the one that's given to you. The 2 pi rh, again, representing that rectangular face, whereas the 2 pi r squared, well, that's representing a circle, pi r squared, but we do have 2 of them. So 2 pi r squared, rectangular label, and 2 circles. Knowing what the variables represent in that, all you have to do is substitute in and solve. So surface area of a cylinder, 2 pi r squared, 2 pi rh plus 2 pi r squared. So now I can substitute in. Surface area is 2 times pi times the radius, which is given as 6, times the height of the cylinder, which is distance between the bases, which I can put as 12. Plus then the 2 circles, 2 times pi times, again, our radius of 6, and it needs to be squared. So there's what we're looking at for our calculations. Formula's given, know what each part of the formula represents from our shape, and solve it. Multiply before adding, so we get 2 pi rh is 452 and 1600ths when I round to 2 decimal places, plus the 2 pi times 6 squared, 2 times pi times, don't forget 6 squared is 36, 6 times 6, not just 12. And we get 226 and 800ths. So if I round it to 1 decimal place, we end up with 678 and 2400ths, or to 1 decimal place would be 2/10 centimeters squared. Formula is given, 2 pi RH for the rectangle plus 2 pi r squared. Understanding what each part represents is going to be important. We'll see in a couple minutes. The next shape is a sphere. Well, if you look at a sphere and you think about trying to unfold a sphere to get the net, well, you're not going to get any kind of shapes we're familiar with. It's almost impossible to truly unfold a sphere or a round object. So we just expect that you use the formula. It's on the formula sheet. It's available to you. Surface area is just 4 pi r squared. All we need to do, surface area, 4 times pi times r squared. We'll substitute in 4 times pi. And we can see, even though it's not a circle, it's a 3-dimensional sphere, the radius is still representing from the middle of the sphere to the edge, which we see is 3.5, and we want to square that. 4 times pi times 3.5 squared. The surface area of that sphere is 153 and 9/10 millimeters squared. That's the ugliest looking M I've drawn in a while. Millimeters squared. Can't really create the shapes individually for a sphere, so we give the formula to you to know how to work with. So those are the first two, and the third one is the cone. The cone, well, again, a cone's kind of special. This diagram shows us that we have a cone, which means there's a circular base. So we have one circle making it up. But if we unwrap to create a net, this second shape for any cone, we can see it's a part of a circle. It's actually, it looks like it's a triangle, and I've had students use the triangle formula, but a triangle has straight edges. And the unwrapped, unfolded cone doesn't have a true triangle. It's a different shape. So again, we give the formula for it. Now the pi r squared, well, hopefully you understand that the surface area represents the bottom circle. If I were to paint this, we'd have to paint that bottom circle pi r squared, but we'd also paint the outside, this rounded part of the cone, and the rounded part of the cone, which is part of a circle, uses the formula pi rs. Now s is a special variable I don't think you've come across before. S represents the slant height. It's the height from the bottom of the cone to the top, or the apex, but it's on the angle, so it's the slanted height. How tall the cone stands, straight up and down, that's referred to as a vertical height. You're going to use that in the future in some math courses, but right now, when we talk surface area, we use this S value, which is the slant height of the cone. So all we have to do is understand, recognize that it's a cone, think of the formula that we're working with, jot it down, and now substitute into it. So surface area is pi times the radius. Well, we can see in this example, our radius of the circle is 4 centimeters. So pi r squared is going to be the circular bottom. Plus, now that rounded face, the rounded part of that cone is going to be pi rs, which would be pi times the radius, which is 4, times, again, the slant height is how high the cone is on the angle or the slant. There's your second face that would need to be painted on the cone. So the formulas aren't overly complicated. You just have to make sure you know which shape, so you choose the right formula and you can plug in accordingly. Pi times 4 squared, or pi times 16, is 50.24, plus pi times 4 times 8, pi times 32, is 100.48. So we know that the surface area of that cone to 1 decimal place is 150 and 7/10 centimeters squared. So when we have prisms, we need to put together the information to create. However, if we have spheres, cylinders, or cones, we can come up with the questions themselves. All right, let's quickly please go to the sheet of paper that I asked you to pull out, and let's take a look at a couple more examples that are kind of unique. So what we're looking at here, question number 1 that I want to add, you can jot this down, but if a company wanted to make plastic lidless garbage cans. So you can think in a washroom or something, sometimes you get these little garbage cans that don't have a lid. How much plastic would be needed to make that garbage can? So it would be a garbage can that doesn't have a lid, but it's shaped like a cylinder. Well, the reason, if you think about it, we go to our formula for a cylinder because that's what shape we're looking at. And let's just, for argument's sake, say it's 40 centimeters tall and it has a 30 centimeter diameter. So it's not big. How would I get the surface area of this? Well, if we think of our formula, 2 pi RH plus 2 pi r squared. Now this one's special. How come? What is it about this one we have to be careful of? Well, the big thing is the fact that it's lidless. If you think about it, you don't have a top on it. It's just always open to put in whatever it has to go into the garbage. So how does that change our formula? Well, the surface area, we still have all of this rectangle piece, but we no longer have 2 circles. We just have the circle on the bottom that would be made of plastic, but because it's lidless, we don't have 2, we just have 1 circle. So our formula, if you think about this particular question, 2 pi RH plus pi r squared. So you have to be careful because not all situations use all parts of the object. So we could plug in 2 times pi times the radius. Well, we said the diameter is given, so the radius would be half of that. And the height of the garbage can, we said, was 40. Plus, we no longer have 2 pi r squareds. We just have 1 pi r squared because we don't have a lid. So pi times radius, which is 15, and we want to square that. So from there, we could do the calculations and come up with the surface area. So what do we get for calculations? We have, do the multiplying here, and we end up with, bear with me a sec, 3,769 decimal 911 plus the second calculation, pi times 15 squared, or pi times 15 times 15, which gives us 706.858. So I combine those two, and when I combine those two, we get our surface area, which is, to one decimal place, 4,476.8 centimeters squared. There's what we're looking at for the surface area there. So, two more quick ones here. The second one that's special. This is always a popular question. If you have a soup can, 7 centimeters wide and 12 centimeters high, what's the area of the label? So they're going to put a label on soup cans. Most soup cans have a label. What's the area? How much material do they need for that? Well, if we think of the soup can, it says 7 centimeters wide. So again, that's your diameter. Diameter 7, so our radius is half that. And it says the soup can is 12 centimeters high. Here's again where you have to think. What's the area of the label? Well, when we're talking soup cans don't have labels on the top. Soup cans have labels wrapped around the edge. So surface area of a cylinder, 2 pi RH plus 2 pi R squared. But since we just want the label, we don't want the top and bottom circles at all. This particular question, little bit of thinking, that's all we have for the label of the can. 2 times pi times the radius, which is 3.5, times the height, which is 12. No need for the top or bottom circle because those don't get labels on them. So when we calculate this, we just have to do the 2 times pi times RH calculation, which simplifies things, little less parts to it. And when we do that, the label would be 263.9 centimeters squared. So again, real life situations use surface area calculations, but not always all parts. We have to think a little bit as to what needs to be used. Last one. I really like this question. If you had a hemisphere, so you've taken a sphere, a ball, some kind of a solid ball, and you've cut it in half, and you want to paint the entire hemisphere. So it's half of a sphere. If the radius was 8 centimeters, this one is a thinker because we want to paint the whole thing. Well, to start with, if we had an entire sphere, say we just had an entire sphere, well, our area, the surface area of the whole sphere, is 4 pi r squared. However, if I cut it in half and I take away the bottom, well, how much of the sphere do we actually have? Well, we've only got now half of it. So I can divide that by 2. However, this is the part that always gets students. We can see from this diagram, when we cut it in half, where it gets cut, we now actually create a circle that also has to be painted. Here's the rounded. This rounded part is here, but because we cut it in half, we create this extra circle. Yeah, that's a thinker. You've really got to think about that one. I like that question. So our calculation, 4 times pi times, it tells us the radius is 8 centimeters, so 8 squared divided by 2, plus now that circle on the bottom that gets created. Pi times r squared. So, again, a little bit of a twist. Makes you think, and it's not always bad to think. Sometimes it's good. Hurts a little bit, I know, but it's good for you. So 4 times pi times 8 squared, and then I divide that by 2 to figure out the rounded portion. The rounded portion here is 402.124 plus pi times 8 squared. So pi times 8 squared. That gives us 201.062. I combine those two things together and round to 1 decimal place. And we end up with 603.2 centimeters squared. So, spheres, cones, and cylinders. Honestly, hopefully it's not overly complicated because the formulas get given to you. But you have to be careful of word problem situations because you don't always have to solve every part. Your assignment for this is pages 48 and 49 in the booklet. In this booklet, finish page 48 and 49, and then supplemental pages. Working with those supplemental page booklet. I want pages 13 to 15, questions number, you don't have to do all of it, 1, 3, 4, 6, 7, 10, and 12. If you have questions, or do those questions, you will be in good shape getting ready for the assessment. So, there it is. The only way to get good with this is to practice. Go practice and have some fun.